Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, here we go with lesson 4.1.3. We are going to develop graphs from rules. So I've attached to the classroom a PDF form that has the table and the graph that you're going to be using for this activity. You don't need to use that form. You can always create your own graph in your journal and create your own tables. So it's not necessary, but if you do have a printer and have the ability to print it off, you might find that to your advantage for this particular lesson. So what are we going to be doing today? All right, so you've been looking at geometric patterns and ways in which these patterns can be represented in tables, right? In output XY tables, graphs, and equations. Lesson 4.1.2, you worked with 4 different tile patterns and looked for connections between these geometric shapes and the numbers in the equations. Today, you'll go back to those 4 equations and look for connections to the other representations. By the end of this lesson, you should be able to answer these target questions. How is growth shown in a graph? How is growth shown in a rule? And how can you determine the number of tiles in figure 0 from a graph? Also, how can you determine which tile pattern grows faster from just looking at the graph? All right, so what we're going to do is we're going to take what we did yesterday or in the previous lesson, depending on when you're viewing this, and we're going to look at our patterns of growth and the rules that we created from those patterns. And we are going to put that information into a table, and then we are going to graph the data from the table. And then we're going to see how we see the growth in both the graph and in the table and in the rule, so we can describe those connections between them. So this is that resource page that I was talking about. Go ahead, get your work from lesson 4.1.2. You have tile pattern 1, tile pattern 2, tile pattern 3, and tile pattern 4. And actually, let me pause this for a second, and I'll pull that up so we can take a look at it. Okay, so I don't have the completed version of the lesson 4.1.2, but here is the that very first tile pattern where you look at figure 1, figure 2, figure 3, you figured out how they were growing, and you created a rule for that situation, and then you created figure 0 and figure 4. So looking at your data from lesson 4.1.2, we are now going to take that information and put it into a table. So it's helpful, we created the rules for each one of those situations. So I'm just going to use the rule. I'm not necessarily going to count all the different tiles on the previous, but you can do it that way. So remember, figure 1 had a total of 6 tiles, figure 2 had a total of 10, and figure 3 had a total of 14, and you had to create figure 4 and figure 0 and then identify the rule. Well, figure 0 kind of has to do with this number right here, right? When x is equal to 0, it doesn't matter what the growth pattern is. You know that y is going to be equal to this. So that's why we knew figure 0 had 2 tiles. And then figure 4 should, if you see the counting sequence, looks like it's growing by 4 every single time. And so the next one has to be 18. And if we plug the 4 in for x, 4 times 4 is 16 plus 2 is 18. So that absolutely completes the table for pattern 1. So what I'd like for you to do is take your rules from the previous lesson for tile pattern 2, 3, and 4, and fill in each one of these tables. I'm going to pause. You go ahead and pause, and we'll see if our tables look exactly the same when you unpause. Okay, let's take a look and see at these tables. You can see with tile pattern 2, the growth rate was growing by 4 every single time. So we created the rule y is equal to 4x plus 1, where the 4 is the growth rate or the growth factor, and 1 is the starting amount, and we always start with figure 0. So when x was equal to 0, y was 1. X was equal to 1, y was 5. X was equal to 2, y is 9. And of course, these correspond to the figure numbers and the number of tiles. So tile figure 1 had 5 tiles in it. Tile figure 2 had 9, 4 more than the previous. Tile figure 3 had 13, and 4 had 17. Moving down to tile pattern 3, the first figure had 7 tiles, the second one had 11, the third had 15. So it had a growth pattern growing by 4. That's your growth factor. And whatever value for x is, you multiply it times 4 and add it to how much you started with. So figure 0 was the starting point, and you had 3 tiles that you drew for figure 0. And then the fourth tile pattern wasn't growing by 4. This one was growing by 2. And it started off with 1 had 5 tiles, 2 had 7, 3 had 9. And so the fourth one had to have 11 because it was growing by 2s. And if you went backwards, the 0 figure would have had to have started with 3. So that's your starting point, and it's growing by 2 every single time. So this is the rule that defines that situation. All right, so what do we do now? Now let's put all of this information into a graph. And then we will just finish the lesson off by looking and seeing where do we see the growth happening in each one of these situations. Okay, so in order to graph, we need to have an x coordinate and a y, or I'm sorry, an x-axis and a y-axis. So I'm going to label the horizontal axis of my graph x and the vertical y. And I'm going to look, and really for my tile figures, I only need to go from 0 to 4. Maybe I'll go to 5 or 6. We'll see how many segments we have at the bottom. And for the y's, looks like my greatest y value is 19. So I need to be able to get up to 19. So what do we count by here? 1, 2, 3, 4. I think we'll just count by ones. So this will be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and the next one would be 20. And that's enough, right? We don't need any more than that. We could go up to 25 if we needed to, but I'm not going to label that. And what do we count by here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Okay, you know what? I think I'm going to count by, maybe I'll count by 5s and have this be 1. 1, 2, 3, 4. This will be 2. 1, 2, 3, 4, 5. This will be 3. So this will be nice and spaced out. 1, 2, 3, 4, 5. This will be 4. 1, 2, 3, 4. And we don't really need to go beyond, but we could go beyond on a number of them. So I'll number it like this. You don't necessarily have to number it like this. If you're creating your own graph in your journal, you can do your numbering sequence any way that you want. Okay, so let's start with the very first table. I'm going to start by graphing my figure 0 point. Where do we see that showing up on the graph? Well, if this is our x value and this is our y value, when x is 0, y is going to be equal to 2. And we want it to grow by 4. So I could either plot each one of these points and connect the dots, I suppose. Maybe we'll connect the dots or not. Yeah, I'll connect them so you can see the line, even though this isn't a lesson about discrete or continuous graphs. So technically, I don't think we should be connecting them, but I'm going to do it anyway, just so you can see the line. So I could plot each one of those individual points, or I can just factor in my growth rate. So every time x increases by 1, y increases by 4. So let's plot this in red, and our starting number, oh, did I already miss it again? What is it? 2. It's a 2. So when x is equal to 0, y is equal to 2. That's this point right here. And now when we increase x by 1, we increase y by 4. 1, 2, 3, 4. So this point is 1, 6, where this one was 0, 2, correct? We're going to graph every single one of these lines on this graph. So labeling might end up making this really, really crowded. I might end up erasing those. So maybe don't put in the ordered pairs yet, because they might all end up running together and it makes a big mess. So I'm going to do it for this one, but maybe not for the others. All right, so let's do the next one. How do we see the growth on the line? When x increases by 1, right, it goes from 1 to 2. Y increases by 4. 1, 2, 3, 4 goes from 6 to 10. So this is 2, 10. And let's just verify looking in the table, 0, 2, 1, 6, and 2, 10. 0, 2, 1, 6, 2, 10. The next one's going to be 3, 14, and so forth. So essentially what I'm doing here is I'm identifying what the growth rate is, and I'm just plotting points in without even referencing my rule or my table. You can do that. So 1, 2, 3, 4, 5, that's 1, right? From 2 to 3, and then 1, 2, 3, 4, and this point is 3, 14, and the next one, that's 1, right? So that's this 4, and then 1, 2, 3, 4. This should be 4, 18. And the reason why it's good to graph these is because once you get a straight line here, you can extend that line and you can find every other point that's going to be on this table. So if I just extend it now, making sure that it stays going through all of those points, it looks like this one right here is going to be a point. What is that? That's where y is equal to 25, and what is x equal to at that point? No, that doesn't really work. My bad, forget about that. But let's try this. 1, 2, 3, 4, 5, 1, 2, 3, 4. Yes, that falls on there. And 1, 2, 3, 4, 5, 1, 2, 3. We ran off the graph, so we're not going to plot that one. All right, so what I would like for you to do now is take each one of these tables and graph these points for y equals 4x plus 1, graph this one for y equals 4x plus 3, and graph this one for y equals 2x plus 3. And, you know, if you've got colored pencils or markers, you can color code them if you want to. Otherwise, you should probably label each one of your lines. Color coding is nice because you don't, you know, you got less that you have to write on the graph. But go ahead and do that. I'm going to now actually erase these guys because it'll get too crowded in here. Go ahead and pause. I'm going to go ahead and complete the other 3 graphs. You complete the other 3 graphs. All right, we got our graphs in now. Now you see why I erased the ordered pairs, because they were going to run into the blue line, and then how do you label the green one? And yes, it's become a bit of a mess putting 4 different graphs on the same coordinate grid. But notice some things that they have in common here. Notice all 3 of these graphs for these 3 tile patterns that all have the same growth rate have lines that are all parallel to each other. That's something that's interesting, and that's something that is worth noting, that when 2 equations have the same growth rate, their lines will be parallel on the graph. Notice how they have different starting points. These starting points are what we refer to as the y-intercepts. These are the points on your graph where your line crosses over the y-axis. That's an important point because this is where x is equal to 0, and this also happens to correspond to these numbers that are being added on at the end. Remember, when x was equal to 0 here, it didn't matter what the growth rate was because y was always going to be equal to this number being added at the end, right? 3, 3, 1, 1, 3, 3, and 2, 2. So these, I'm going to highlight, this is your y-intercept, which corresponds to your starting figure 0 in your tile patterns. And the y-intercepts, let me go ahead and show it here, and here are all of these points where your graph crosses over the y-axis. So basically, I can make up any rule now, and I can tell you where the one of the points is going to be. So if I take, let me choose orange. Let's take, I'll do it right here. Y is equal to 3x plus 7. I know that 7 is going to be my y-intercept, because when x is equal to 0, y is going to be equal to 7. And now let's look at the growth rates. Where do we see the growth happening in each one of these tables? Well, the growth is how much it's adding every single time. Notice how that's the same for the first 3 tile figures. They all have the same growth rate. Same thing here. We'll do it in green. 1 plus 4 plus 4. plus 4. And the one that was different was tile pattern 4, where this one was growing by 2. Okay? Now, this only works when you make sure that your X values are counting by 1. That's important. So it's always good to have these tables in order. But notice the connections here. I'll do this in light blue. The growth rate is 4. That's what the counting sequence here is for your number of tiles. The growth rate is 4. That's what the counting sequence is for your number of tiles. The growth rate is 4. Counting sequence, counting by 4s. And this one is 2. It's counting by 2s. So how do you see this showing up in the graph? Well, it has to do with this. Let me go ahead and connect 2 points here. Let me go, say, from this point here to this point here. Between those 2 points, I'll label these 2 points. This point right here was, oh goodness gracious, what was that point? That was at 4:17. And the next point right here was at 5:21. So how much the X increase going from this point to that point? It increased by 1. How much did Y increase going up? This increased by 1, 2, 3, 4. Now, one thing I want to tell you is you have to be careful with your counting sequences down in your X-axis. We're not counting by 5s, even though you see 5 lines there. Each one of those represents 1/5, 2/5, 3/5. Each one of those is a 5th or 2/10. We're counting by 1s on the X-axis because those are what I've labeled, and each one of these points increases by 1 as you go. So to go from here to here is 5/5 or 10/10 if you want to think of it in decimal form, but it's really equal to 1. The distance is 1. Pay attention to your counting sequence, not the individual number of lines when you do this. And because on the Y-axis you are actually counting by 1s for every line, then we will count every one. 1, 2, 3, 4. So where do we see the growth rate here? We see it in this ratio, which we refer to as the change in Y over the change in X, which is 4/1, which is equal to 4. So let's come back to this orange graph that I'm about ready to create because I just made up this equation. Remember the y-intercept was at 0 when x was equal to 0, y was equal to 7. And the growth rate is right here. That's the growth factor. That means for every time that x increases by 1, y will increase by 3. So I'm going to go 1, 1, 2, 3. 1, 1, 2, 3. 1, 1, 2, 3. And then we could connect these points if we wanted to as such. Okay, so where do we see growth happening in the rule? It's the number that's being multiplied times x. Where do we see growth in the table? That is how much the y value increases for every time the x value increases by 1. Where do we see it in the graph? It becomes what we call a growth triangle, where you get the change in y over the change in x, or what sometimes we will call the rise. That's how much it goes up. That's the change in y over the run. Okay, so let's make sure we got everything. What connections do you see between these representations to explain how the growth appears in the pattern, in the table, and in the graph? It would be good for you to write out just a bit of a statement there of how you see growth appearing in each one of those representations, okay? But if you need to go back and rewatch the last 5 minutes where I'm describing where we see that growth happening in the rule, in the table, and in the graph, go ahead and rewatch that and see if you can put that into your own words. But as we move forward, understanding these connections is going to make it so much easier for you to complete your graphs, complete your tables, identify your rules, and then essentially solve problems that we're presented with after using these tools. Okay. All right, so that was a pretty fast lesson, not too bad, under 20 minutes, although I'm sure you took a fair amount of time pausing and creating your graphs, so it's probably much longer than that. All right, take care. Let's move on to our, I guess we would move on to our check for understanding, wouldn't we? before going on to the homework. All right, take care. Bye.
Hey, feeling good, like I should. When in dark, I walk around the neighborhood. Feeling blessed,